the end-to-end security is not just for one person, right? Like the end-to-end security affects the entire spectrum of users of today's World Wide Web. So that's a topic of the day. And certificate pinning is one of the technology that's being used by most of the services and most of the applications today for providing end-to-end security. We just want to talk about what is certificate pinning, why it has become so popular, why end-to-end security has become a big topic of the day. And we also want to talk about, if you're a developer, how do you enable certificate pinning in your apps? And we also want to talk about what happens when you're an IT administrator and the world becomes an end-to-end secure world and you lose all the visibility of your network traffic. That's the biggest issue that the world, like everybody is facing, because Google and Facebook and all these other guys have moved towards end-to-end security. What happens to the IT guy who's stuck in the middle, who cannot do anything right now because nothing is clear? All he sees is an opaque traffic packets going through his firewall and just is sitting in a blind spot. So the first thing we want to, like the agenda for the meeting is, we want to talk about what happened with this traditional SSL. We all heard SSL is very secure. Once you have SSL in your network, everything is happy. You don't have to worry about malwares, snooping, or anybody stealing your data. Even you see all the advertisements that say like, look for the lock icon on your browser. Once you see the lock icon, world is safe. Be happy. You are completely foolproof, right? And that's not the case. Like, so the whole certificate model is being broken, and has been broken for quite some time. And then, how did certificate pinning arrive? How did that become the de facto model for end-to-end security? And then we want to talk about what happens now. Like, okay, you've got end-to-end security. What happens to the IT guy? What happens to the CIOs who are sitting there? What happened to all the service providers who are using the visibility in the traffic for network optimization and all the other stuff? And what do we do now, right? Like, this is what has happened. What next? So that's the agenda for the day. So where did it start? The first thing that started breaking the certificate trust model is the certificate authority is not one person, right? It's not RSA that's issuing all the certificates. There's like so many sub authorities and end nodes and everyone. There's a tree. There's like 20 different certificate authorities that are issuing certificates. You go to your web browser like Mozilla or something and you look at the list of trusted CAs. There's like hundreds of trusted CAs. If one trusted CA issues a malicious certificate or issues a certificate without validating the entity, or if they are hacked, right, that just opens up a can of worms. So what happened, like you've seen like certificate authorities like Bit9 and Komodo, they've been hacked and then they lost their root certificate and they never realized the fact they lost it. And then for weeks and months and everything, you see malware spreading across the board, or traffic being hijacked without the users ever being aware. Because all the users care is, do I see a lock icon on the browser? I see a lock icon, that means it's SSL, I'm good to go. But they don't understand where this SSL is landing them to. It's actually taking them to a pirated website or something that's like injecting malware traffic into their computer, right? Just because you have a SSL traffic and encrypted traffic leaving your network or leaving your endpoint, it doesn't mean it's secure. So that's the biggest problem that the whole thing of PKCS and CA. That means once it's SSL, once it's encrypted by SSL, everything is good. That is not the case. And the other thing we have seen is several cases where Microsoft has several code signing certificates and root certificates where one or two certificates get stolen because they have so many different regional certificates, one for China, one for Asia, one for Europe and everything. If it leaks somewhere in one remote corner of the world, and if somebody is able to use the certificate to like create malware and then install it on your PC, we never realize it. It always looks like it's a valid piece of software, right? The big problem with the certificate authority right now is there is no complete loopback system of making sure every single certificate that is issued today is issued with a valid cause, and the keys and the root certificates that are used for creating the certificates are foolproof and kept safe. Because once it's hacked, you have to wait for the revocation of the certificates, And the revocation could take a long time. And that cycle, between that period of time, you could lose millions and millions of endpoints for malwares and spywares. The next thing you probably have seen in the recent times, in the recent year, is the scare that is created by Snowden and other whistleblowers. They've created this whole thing about whatever that goes through your network, it doesn't matter, it can be read by a centralized monitoring authority, right? It can be SSL, it can be voice, it can be anything that you send outside your endpoint. It can be whatever it is, right? Through your mobile network, through your PC, can be monitored. And which is proven true, which is like there's so many things that's been proven that like this is happening on a day-to-day basis. A typical NSA snooping happens. They don't actually intercept the traffic. They don't block the traffic. All they do is they passively log most of the traffic. They create a secondary bifurcation channel. They take a copy of the existing data. They start archiving everything, and then they do an offline analysis, right? It's going to be a call from FBI saying like, hey, did you post a bomb threat? It's not going to be like once you type bomb on Facebook, it's going to block the traffic. So basically, most of the users never feel the intrusiveness of NSA snooping because NSA doesn't do inline snooping. NSA, what they do is they work with ISPs and they work with providers to say, give me a copy of all the network traffic. Let me do analysis. They have their own algorithms. They just don't go by simple keywords like bomb and other stuff, but they do behavioral analysis and they figure out, is this particular user behavior request needs further analysis? Do we need to have FBI or local authority come and talk to this guy and see what's happening? So that's the snooping model that's being followed by Western things like British and NSA snooping. The other thing we hear is the Great Firewall and the Great Cannon. Most of you guys probably heard the Great Cannon, which was used for DDoSing GitHub a few weeks back. It's simple. Basically, previously, a year back, if somebody said DDoS, a lot of people thought it's the zombie pieces sitting across the internet and the malware can be activated for flooding traffic. And that model has been deprecated for a long time. You don't need zombie PCs. All you need is to be able to redirect traffic. So all what Great Cannon did is they redirected all the traffic that goes to Bing, and then they redirected half the traffic to GitHub. So whenever you see a web page today, not the entire web page comes from the same website, right? Like you have advertisements, you have several URLs that are like redirects where you have aggregates of data coming through, and the final HTML is what you see. So all you have to do is, if you take a Bing web page, if you intercept the Bing web page and inject a small JavaScript file saying, go to the home page of GitHub, that is enough to redirect billions and billions of connections to GitHub, which could just bring it down in nanoseconds because GitHub was never built to handle that much traffic. So what the typical Chinese model is, they have two ways. Whenever traffic leaves or enter one of these Chinese main network, they have a Great Firewall, which is doing inspection. They do the other way of doing inline scanning compared to a typical NSA snooping, which does offline storage and analysis. If you post a bomb threat in like in Facebook or some other website like in China, it can instantly block it. They can say, okay, this particular traffic seems to be creating problems. Let's do a TCP deny. So they do an inline inspection. So they do archiving like NSA, but they also do an inline inspection and block traffic if they decide you're not supposed to access this particular website, like maybe Facebook or something else from China. They can do an inline inspection and stop. That's the Great Firewall. And they also can do JavaScript injection or HTML rewrite, where they can use a current existing traffic going to a popular website and redirect it to some other website for DDoSing. So all of them are using encrypted traffic. These are not traffic that are not encrypted. So previously, the expectation was if you're using clear traffic, somebody could attack the traffic by snooping or redirecting traffic. The whole man-in-the-middle attack. If you look at if you read the description of SSL, SSL simply says, oh, if you don't use SSL, somebody could do man-in-the-middle attack. You don't need to worry about that. Even if you use SSL today, it can still do man-in-the-middle attack. Almost 80% of the man-in-the-middle attack performed today are on SSL traffic. How do these guys do it, right? We heard it in textbooks. We read RFCs. We read so many presentations and everything that says, once you have SSL, you're good to go. You see the lock icon on the browser, world is safe. Your bank transactions are safe. All your traffic is perfectly handled. Only person who can see the data traffic is the service provider. So where did it all fall apart? Where it fell apart is you got commodity hardware that can decrypt at amazingly high rates. You don't have to spend billions of dollars to decrypt terabits of traffic. Today, you have very cost-effective SSL interceptors using off-the-shelf hardware. The other thing is a simple concept of doing MITM proxy. What MITM proxy does is, so basically they take advantage of the fact we have a whole bunch of CAs that are trusted in our web browser. You take a web browser, we have service provider CAs that are being trusted. So all a service provider has to do is, let's say you are a PC that's trying to access google.com. If you go to the lock icon on your browser and you click on that icon and look at the certificate, it'll have two important fields. One is who's the issuer of the certificate? That's the guy who signed the certificate. And who is the common name? That means what are you trying to reach? Is it Google or mail.google or whatever that thing is? But when you have a MITM proxy in between, if you check the certificate at that time, the issuer will not be Google. The issuer will be your service provider or your IT administrator, your corporate office certificate. Basically what they do is you first try to establish a SSL connection to Google. The MITM proxy in between determines that, okay, this is a new SSL connection. It creates a fake Google certificate using its own CS certificate. It signs itself. And then it establishes SSL connection between the gateway and the PC. From an end user, the PC is very happy because he sees a lock icon. He sees, oh, the data going out of my PC is encrypted using SSL, but it's not encrypted all the way to Google. It's only encrypted till the access point or the SSL interceptor that's present in between. And then the SSL interceptor gets a complete clear traffic. And then it actually puts in a different tunnel and it goes out. This is what happens today across the world. This is how all the NSA snooping, Great Firewall, all of them work because we never realize where the traffic gets injected and all this other stuff. Like this is one other thing you hear like in UTM gateways from several vendors. They say, oh, we do decrypt SSL traffic. This is a simple thing. Basically what they do is when your endpoint comes into office or something, they install a CA certificate on your browser, and then your browser always trusts your router gateway to be a CA. This is one of the simplest way to do MITM hacks and everything. So you've seen several problems, right? Like SSL itself can be intercepted. Users are not smart enough to understand the traffic is not encrypted end-to-end. You hear things like NSA snooping. You hear things like China Great Firewall and all this other stuff. Now, if you're a vendor like Dropbox or Facebook or Google, you want your users to trust you. You don't want them to feel, oh, if somebody comes and posts something in my website, it's going to be, everybody's going to know what's happening. Like privacy issues and so many other things happen. Like a lot of people don't want to upload their entire backup to Dropbox, right? Like that becomes a big problem because they know like whatever they upload to Dropbox is being seen by someone, is being archived in some remote warehouse somewhere, right? So that's a big concern. So as a vendor, as a business provider like Dropbox, I want to make sure my users are happy. So what do? You work on certificate pinning. You make sure your connection is directly to the user and not with anybody else in between. So the users trust you. So that's how certificate pinning started. Basically, all these vendors like Gmail, even if you use PC, if you use a Google Chrome does certificate pinning. It makes sure when you log into Gmail or Google, you're actually logging into Google. It actually validates to make sure the issuer of the certificate is Google and not some in-between CA. So yes, certificate pinning has happened. All the users are very, very happy now. Google makes tons of money. Facebook is making money. Nobody cares about, everybody's happy that their privacy is taken care. where does the IT guy stands now, right? I'm an IT guy. I've installed IT security. I went and bought a data leak prevention. I bought a deep packet inspection firewall. I bought a mail security. I bought secure web gateway. I bought an IDS box. I bought all sorts of stuff, assuming all of them can see the traffic that's going through the firewall. Nothing is visible now. You cannot decrypt the traffic. All my IDS, IPS box, the green lights are not blinking. They're just sitting there, right? Like, you've spent millions and millions of dollars. Overnight, the certificate pinning started happening. They lost visibility on the traffic, right? Like, your signature basket, AV scans on the box, they're not getting any traffic at all from the firewall, right? Like, the typical architecture is you have a firewall that's analyzing the traffic, and based on some patterns, it redirects some traffic to DLP, some pattern of traffic to IDS, all these other stuff. Nothing is hitting it because all it sees is encrypted packets going in and out of the system. What does IT guy do, right? Like, so just you're stuck in a limbo. You've spent millions and millions of dollars. You've created this beautiful network architecture, including video caching. How do you offload? Basically, when somebody's accessing video files from YouTube and everything, frequently accessed YouTube files can be cached locally. You've created this beautiful network, big corporate 500 company, Fortune 500 company. You've done this extensive work. Now you're stuck. YouTube is encrypted. Google is encrypted. Just basic stuff. Every single thing is now encrypted, right? You can't even cache image files. So that's, hello? Can you hear? Okay. So that's the problem today. So what has helped some people? What has helped some people are now impacting the other set of people, which are the IT administrators. Yeah. So what has helped the end users and the service providers are severely impacting IT administrators. So the other problem is, previously you had this firewall and you had Salesforce and you had all this beautiful system for making sure nobody's copying data from Salesforce and uploading to Dropbox. That model is completely broken. You got a phone, you got two apps, you can copy data from Salesforce to Dropbox, because the data that's going through Dropbox is just going to zip through your firewall with no visibility, right? All your data leak prevention schemes that you installed are worthless right now. So that's a big problem a lot of IT administrators are facing today. This is a very rapidly going problem with, like, most of the things, because all your analysis, including IDS, IPS, DLP, everything is based on the fact you have some visibility on the traffic. Once you don't have any visibility on the traffic, it's going to be very difficult to do any real useful analysis on the traffic that's going outside your network. And who else has joined this party? It's our Linux guys, right? Today, if you're a small app developer, if you want to do certificate pinning, or if you are like a big data center, if you have like hundreds and hundreds of servers geographically spread across the world, if you want to do certificate pinning, you need to buy certificates for every individual server out there in the world, right? So the cost of creating certificates and paying RSA is just going to grow astronomically. Also, let's say if you move from Amazon to some other AWS to something like Azure, your domain names are going to be different. So you need to purchase a different certificate. So all the cost of making certificates is getting very, very expensive, right? Like, so if I'm a very small app developer, my whole budget was $100 that I paid for buying an iOS developer account, and I'm just publishing a small app, but I want to have certificate pinning. I don't want to go through RSA, validate that I'm a valid business, and make sure I have a certificate account. There's two ends of the spectrum. One is I'm a very low-end guy. The other is I'm a big, massive data center running hundreds and thousands of servers across the world. For both of them, it becomes very cumbersome and costly to chase some certificate authority, buy certificates in bulk, and make sure all of them are taken care of, right? Here's where Linux Foundation comes in. They created this project, which was there already, but Linux Foundation adopted it, which is called Let's Encrypt, which is going to be a free CA for everyone. It provides you revocation. It provides you domain validation. And it's a complete CA service. It's an automated CA service for everyone. And this one is going to drive up certificate use everywhere. Like previously, if you're an IT guy and if you wanted to have client certificates, like thousands of client certificates per users, it was just astronomically expensive. Or if you're a big, massive data center and if you want to have thousands of certificates and you want to change them, you want to move from one geographical location to the other, the costs were so expensive and you have to go through budget approval and you have to go through planning. Right now, nothing. It's this free CA run by Linux Foundation and it's being sponsored by all the big vendors like Mozilla and Cisco. They're all joining the party. They want everything to be encrypted because more you encrypt, more boxes they can sell on the other side for load balancers and all the other stuff, right? So they like the idea of everything being encrypted. Application developers like it to be encrypted. End users like it to be encrypted. There was an in-between CA that was just sitting there and saying, I'm a gatekeeper, you guys have to give me a whole bunch of money. And that's where Linux Foundation coming in to democratize the whole CA system. So now you've got a free certificate, or you could just go to your typical CA vendor, got a certificate. How do you actually implement certificate pinning, right? So a certificate pinning is on the app that's on the end user mobile device. What you do is you take a copy of your certificate, the certificate that you're using for hosting your applications on the web. So you take the same certificate, pass it on with your mobile application, and the mobile application, after the SSL connection is established, can verify to make sure the certificate is exactly the same. If you want to do like 100% bulletproof way of doing certificate check, you check the actual certificate itself. But the problem with that is, let's say if you're Facebook, your mobile users could be connecting to any different kind of Facebook server, right? It would be facebook.seattle.com or Facebook located in San Francisco or Facebook related in so many other places. So storing that many certificates inside an app for making sure certificate pinning works is going to get very, very cumbersome. Also, let's say if you want to add a new geographical location, or if you moved your server from Amazon to Google Cloud, so your certificate pinning, you have to create a new version of the app, and you have to send with a new patch of certificates. So instead of that, what the other thing people do is they just want to make sure the actual certificate is signed by the person that Facebook uses. So Facebook or Google, they act as their own certificate signing authority. So what they do is in the certificate pinning on the app, all they do is to make sure they check whenever the connection is established, the certificate is actually signed by Google, not by in-between MITM proxy. The disadvantage with that is you need to store the key password on the app. But that's the most common way of doing it, because as you have a wide sprawl of servers spread across the world, storing the entire list of certificates that this app could be connecting to becomes very expensive. As I was talking about, if you are a developer, which way do you go? Do you want to go with root key-based certificate pinning or a certificate-based certificate pinning? It's up to you. If you are like a small guy, all you have is 1 or 2 servers, a simple certificate-based pinning will be enough. But if you're a massive data center with thousands of servers spread across the world, you are better off with going with a root key-based certificate pinning. So now we have free CAs. It's very easy to implement certificate pinning. You just decide which way you want to go, the root certificate way or the way of doing individual site certificates, right? So what does IT do? IT, they have more and more people are using mobile apps. Like what was PC-based world is now transforming into mobile world, and you lose a lot of visibility on what's happening in the mobile world, because every individual mobile world is an app, right? Everything is now an app, not a HTML page. The traffic is all their own stuff. The other thing is you have brought millions and millions of dollars of IPS, IDS, web gateway, and all these things, expecting to get some traffic from your inspection engine, which is your firewall, to identify the different kinds of traffic and then pass it along to IDS, IPS boxes. And they're not getting any data right now, right? They're just sitting there idle, not knowing what to do. What do you do as an IT guy, right? We hear from a lot of big Fortune 500 companies or companies that are heavily invested in security, simply saying, turn off certificate pinning traffic. All they do is they go to their firewall box and say, if you don't know what this traffic is, just block it, right? Which means you go inside their office, you're not going to be able to access Verizon, you're not going to be able to see your baby pictures in Dropbox, or you're not going to do anything, right? Like, it's completely done. You can't even use your Microsoft Office on your phone, because Microsoft Office on your phone is using certificate pinning to store data back in the cloud. So everything is off. All your phone is just used for nothing, right? Like, you just use your phone to pick up your phone call, and there ends the story. That's one end of the spectrum. The other end is to say, just hope and pray nobody uploads all our company information to Dropbox and let them use Dropbox so that we don't piss off all the users. That's the one end, right? There's no easy middle way to come fair where we are, because there's no way to encrypt see what's going on in the traffic. Either you let them just be an open, blind channel, trust your users and say, hey, don't do anything stupid, just give them like a HR advice, or you just block all the traffic. That's where most of the people are, most of the IT guys are faced with these two choices. One is go to your HR and say, please conduct HR training to everyone saying, don't upload, don't download, I'm going to trust you. But users can never be trusted. That's the real world problem. The next thing we see is IT guys getting completely desperate. Right? Their CIOs and CSOs all are screaming at them. They're saying, what is going on? Like, you asked me for all this IT budget. I gave you all sorts of money. You bought this beautiful fancy boxes, and the fans are not even running in that room. Everything is just happily sitting in power down mode. What went wrong, right? Like, what worked a year back? They gave all these beautiful fancy charts and attack detection and threat vector, and all these beautiful boardroom meetings are worthless right now. So what does IT guy do? You're desperate, right? You don't want to lose your job. So what do? They just go and install complete hacks on their endpoints. They go and disable trust validation. So let's say if you are an app that's expecting for SSL trust validation by checking the trust store, if you disable the whole trust validation in the SSL stack of the endpoint, yes, beautiful. You can be an MITM proxy in between. You can do whatever you want to do. The apps are going to think it's actually connecting to the remote end node. They're going to work, but you're actually leaving the entire system vulnerable. It's not even just your MITM proxy. Anybody else could hold a MITM proxy at the remote side and hijack all your traffic, right? So being desperate and going crazy and then disabling the entire trust validation is not an option, but a lot of people are doing it right now because there are so many open source projects available. Like, even you saw Lenovo installing Superfish, right? That's the same thing. Superfish is even licensed by several endpoint security vendors to act as a MITM proxy so that you can inspect traffic. And you saw what happened to Lenovo. Once it becomes a public, once users are aware of the fact that their PCs are completely vulnerable and whatever they do can be seen remotely by a different user, it's going to cause more problems, right? And also the problem is whenever the device leaves a managed node with all these hacks like Superfish or Android SSL bypass installed, that device is completely vulnerable. It doesn't take more than few seconds for the device to fall prey for a malware. So please avoid IT desperation, but this is happening because they want a quick fix. They want to see the data traffic going through the DLP box, right? They don't want the DLP to sit empty. So just come back to the original thing. If you have some developers here, I come from a developer background. I like to see how things are written and everything. If you're an Android developer, if you're an iOS developer, how complex is it to implement certificate pinning? It's not that complex. We just want to give you a simple way. It's very simple. If you look at Android, right? Android has gone a lot far to making sure you can implement certificate pinning with just like maybe 30 lines of code. If you look at Android, it has classes. You can go through the docs for Android. You can look at these classes for the Trust Manager and the Trust Manager Factory. That's the one it gives you. You can take your current existing SSL session and using the Trust Manager and the Trust Manager Factory, you can make sure that particular cert is from a trusted CA of the list of CAs that like CA certs that you provide. And also you can make sure to compare your current cert with the SSL session cert within like 4 lines of code. It's so simple. So that's one of the reasons where you see more and more guys. So here's the thing, right? You have Let's Encrypt from Linux Foundation giving you free certificates. Android adding certificate validation, like cert pinning, so simple. All you have to write is 30 lines of code, and the entire code is actually written for you in the Trust Manager factory. You just have to call few APIs to make sure the remote endpoint is a valid one. So that's one reason you see like more and more people are saying, okay, it's not that expensive for me. I have a cert, I already have everything, the APIs are already there, adding extra 30 lines of code, let me just add it. That's the reason you see like a flurry of new apps. Every new apps that you see is now comes with certificate pinning. Even the simple things like Microsoft Office for Android and all these things come with certificate pin SSL connections. The other question, if I'm an IT guy, I can ask a simple question. It's a nightmare. I have certificate pinning. I cannot see the traffic. All these guys are walking with their Android phones and iPhones and everything. Why do I even bother with BYOD? Let me just say no to BYOD. I give everyone a PC. I disable the trust store in that PC, or I won't let them use Google Chrome. I'll say everybody has to use IE, and then I just be an MITM proxy and continue to live where I am, right? That's another option. But there's a fight between your CEOs and the CIOs and CSOs, right? The CEO wants to make more money. He wants to improve productivity. He wants a user to be available to do the work 24/7. And he says, figure out the security around what I want, right? You cannot restrict your corporate growth because it's not secure to do it. That just doesn't work the other way. You want it to be the other way. You want to grow at like blazing speed. You want to just reach the moon. While you reach the moon, you want your IT guy to figure out how to make the path secure, right? It's his job to make the path secure. It's your job to tread uncharted security, like paths, right? So that's the trade-off between your CEO and the CSO, CIOs in the company. Everybody is fighting for their own way. Right now, the IT guy has become the roadblock in your growth path of your company. And you see more and more applications, including like if you go to a retail store right now, if you go to a doctor's office, most of the doctors are now carrying an iPad, right? They don't want to have an old PC, lugging it around and everything. So everywhere, including you probably heard things about like IBM working with Apple for providing an iPad for all the pilots. So more and more devices, like mobile devices, are being used for enterprise applications. The days when you have to go to an airport, look at an air hostess waiting in front of a terminal to look for a schedule is gone, right? You want everybody to have an iPad in their hand, find schedules. You want to go, if you go to a hospital, you go to a optometrist. Everybody has an iPad. They can just instantly scan your data and they can tell you where you are, right? They don't need to go through all the manually entering information, calling the back-end office and other stuff. So saying no to BYOD is not an option. So far, we just talked about a generic issue of certificate pinning. We talked about why all these providers like Google and Facebook were forced to use certificate pinning. And as a developer, how it is easy to implement certificate pinning. What are the tools that are available for you? You have very easy to use SDKs from Android and iPhone. You have free certificates from Let's Encrypt. So as a developer, you do that. So that's the thing. So what we discussed so far is, just to summarize what we discussed, is why do we need end-to-end security? How do you implement end-to-end security? What are the tools available for you to implement end-to-end security? And what are the problems the IT guys are facing? Everybody else is happy with end-to-end security except for the IT guy now, right? Like that's the world has become. All the guys have joined hands together. The end users, the application providers, all of them have joined hands. They all become one side of the party. They are all very happy. The guy who is left alone is the IT guy who is like screwed. He's like, I don't know what to do now. So the next thing we want to talk about is that one of the ways you can solve some of the problems is using virtual mobile infrastructure. So just to give you what disclosure of what we are is, we are one of the providers of virtual mobile infrastructure. So it's not like an unbiased picture or anything, but what we're here to discuss is, as an IT guy, what are the options that are available for you for doing to handle encrypted pinned certificate pinned traffic. Just to give a brief overview of what VMI is, I'm not going to go in several details of VMI. VMI is similar to VDI. Most of you are aware of VDI, which is like hosted Windows services like RDP or full Windows desktop, where you host a Windows desktop on a server and people access it remotely. Instead of hosting Windows, you host Android. That's the difference between VDI and VMI. VDI is for desktops, VMI is for mobile. There's few differences. Basically, because it's Android, you get better density. You can do a little bit more, like it's more touch-based, and you can use your existing Android apps. Let's say if you're using Dropbox for Android, you don't need to ask Dropbox to develop a new app for Windows or other stuff. You can just use the existing apps as it is, but it's hosted remotely. So this is a typical architecture of VMI. VMI apps are hosted in the centralized server, and you can access them anywhere with no license restrictions. Because if you look at the typical Windows, right, Windows has license restrictions. If you have a Windows server with 1,000 users, you need to buy 1,000 licenses, etc. With Android, there's no user restrictions. So it's cost effective, it's cheaper, higher density, and also it's mobile friendly. So end users can use what they use today without needing to learn a new interface or worry about mouse pointer on a touch device. So a typical way of doing VMI is two ways. One is mobile app virtualization, which is similar to RDP. How many of you are aware of RDSH or RDP? So RDP is basically you have one server, you host multiple apps, and the apps are delivered to the remote client through a remote protocol. And the VDI is hosting a full user interface. So mobile app virtualization is similar to RDP, where you host multiple apps on an Android runtime remotely, and you deliver them remotely to the user. So if you are a user, if you're a corporate guy using remote mobile app virtualization, this is how my phone is going to look. I have Facebook, which is directly running on my PC, and Facebook, which is hosted on VMI, right? The VMI apps are running on a remotely hosted box. The box is hosted by the enterprise, which is your IT. So using VMI, how do you analyze encrypted data, right? Like the data is going through your network. How do you use VMI for analyzing data? There are two ways of doing it. One you can do on the SSL stack itself. The other thing you can do is on the container level. The apps that are hosted remotely on the VMI are hosted in a container, a secure container, and the container acts as an OS abstraction layer between the apps and the operating system. So it can intercept all the network traffic that is leaving and entering the app. It can also understand all the file and the content that is being passing through the app. And it can also understand app behavior. Is the app supposed to do a particular kind of thing? Are they doing like downloading a lot of data? Or what kind of app behavior the user is performing, right? You can do app behavior analysis. You can do network scanning. You can also scan all the other things like you can also use for like recording a video session. Let's say if you find some malicious behavior, you can use that to record the video session of the user and see whether, and then you can do offline analysis. So this is one method of doing, if you're an IT guy, instead of letting them, for BYOD, instead of letting the apps be running natively on the device, you host the device on your own managed centralized server, which gives you better control, better visibility. So now you answer both the questions. Now you let your users use Facebook, Dropbox, whatnot. Also you have a way to inspect to make sure they are not uploading your corporate sensitive information to Dropbox. So the other method is using a secure SSL proxy. So previously I discussed, right, like one of the things that IT guys do is they get desperate, they go completely disable the trust store or the trust mechanism in an operating system, allowing them to run MITM proxy. But the problem with the MITM proxies are both the IT guys are opening a big can of worms, right? Once you allow an MITM proxy to be running on a network, you could have a chain of MITM proxies. Once the data leaves your network, there could be one more MITM proxy sitting up higher up on the network that could be used to intercept traffic. So what you want to make sure is, as an IT guy, you want to be able to inspect the traffic, and you want to be the only guy who's able to inspect the traffic. You don't want anybody else to sit between you and the actual business like Google or Dropbox to be able to drop and inspect the traffic. So that's where we work with like the VMI and some of the vendors who provide SSL proxies, trusted SSL proxies. They're coming up with a new protocol and a new infrastructure called Trusted SSL Proxy, where basically only the gateway that is approved by the IT, or the only one particular box, can act as a Trusted SSL Proxy, and the rest of the connection has to be directly secure. So what they do is, you saw some of the APIs like the X509 trust store validation, all other stuff. So for that, what you need to do is, from the SSL state machine, there's a modification to the SSL state machine that is required. What it does is, today the SSL state machine, all it does is it maintains a peer certificate. What we do is we also maintain the tunnel certificate, who is the actual next endpoint. So the tunnel certificate will tell you where from the, let's say if you are the VMI host, the VMI host also knows the SSL certificate of the connection. It also knows the certificate for the actual end tunnel. The end tunnel certificate is what is the Google certificate, right? So both the certificates are passed to the state machine on the VMI host. When the VMI apps that are calling, when they try to validate the trust store, they actually validate the tunnel certificate, not the actual certificate that is used to connect to the router gateway. So previously you used to have only one certificate for the connection, SSL connection, right? Which is the certificate that is used for encrypting the traffic that left the endpoint. Now you are going to have two certificates. One is your certificate that's used to connect to the endpoint, like for encrypting the traffic leaving the endpoint. The other is a certificate that's used to tunnel data between the SSL proxy and the server, which is google.com or whatnot. So all the trust store validation and everything is all performed on the tunnel certificate. So for you, you are going to trust your proxy, and you also have a hold on the proxy right now to make sure the proxy is not allowing any more MITM proxies in between this and the tunnel. So from the SSL proxy on the end node, the tunnel is guaranteed to be a straight end-to-end tunnel. So the IT guys get the advantage of able to see some visibility on the traffic. The end user can have some peace of mind saying, once the traffic leaves my network, it's not being hijacked, or it's not being profiled, or it's not being snooped upon by anybody else. It's a traffic that's going to the cloud. So the trade-off here is you are giving some front-end key. It's kind of like giving you a key of a copy of a key to your, like a servant maid or someone. You trust them. You trust them to come and clean your house, but you don't want anybody else to come into your house, right? That's the kind of thing this is approach. The approach is you let your IT guy to see the traffic, but nobody else can see the traffic. So it's kind of giving a front-end open key to your IT guy and say, yes, I have to be part of the ecosystem. I have to trust you to be able to inspect my traffic so I can access Dropbox inside Office. So there are three trade-offs you can do. One is you can give a key to your IT guy, or you have your IT guy block the entire traffic, or you can have an unsecured network, which most of the IT guys are not willing to do, right? So this is one of the things. The Trusted SSL Proxy is going to start showing up in more and more boxes. More and more vendors are working with like endpoints and VMI gateways to come up with this model, because you need to have some in-between way, right? You cannot simply say, I'm going to allow you to use Dropbox with no visibility, or you cannot simply say, I'm not going to allow you to use Dropbox inside my office. There has to be an in-between approach where users know that previously when you access Dropbox from your office, it was intercepted, it was analyzed, right? Forever, that was the model. And the certificate pinning that was mainly used to circumvent or avoid the problems of government snooping and the other bigger problems now has broken the enterprise IT. So this is one of the things that being proposed by several vendors on the SSL proxy and the other areas to solve this issue. The other thing that VMI can do is it can do complete monitoring, because the entire app is running on a remote hosted gateway. You can do, let's say if you're using messaging apps, you can basically say, okay, if the message is being sent to a particular user, or if the message is being sent to a particular broadcast group, or you can use any kind of ACLs to monitor the particular behavior of the user. So you have a lot more option for monitoring the user behavior and the type of operation the user is performing. So just to give most of the discussion about certificate pinning is done. I just want to give you like a final thing on, like, if I'm an IT guy, yes, VMI is helpful. how does VMI help when the guy takes a cell phone out of my network, managed network, right? What am I going to do? Your enterprise apps are still protected because your enterprise apps are actually hosted in your own controlled managed network, right? It's not hosted outside your network. So even if the end user leaves the office, your enterprise apps are still protected. You can still make sure nobody can copy data, steal data. You can still make sure all your data leak prevention schemes are being enforced because the enterprise apps are always hosted in your office through a VMI gateway, and the data traffic is always routed through your own managed network. And the other thing what we can do is, because all the phones now use ARM-based processors, all of them have TrustZone-based hardware security. With the TrustZone-based hardware security, you can completely bypass Android, and you can use the TrustZone-based hardware model for rendering the actual user interface and also accept user input. So the Android, let's say if somebody brings in a phone which is rooted and they have the complete kernel of the complete access to the kernel, right? Most of the phones you buy today allow you to install SignaMod or anything else, which allows you to root the device instantly. And you can install whatever rootkits you want to install, or install however you want to disable, you can disable and do it, right? Like you can disable MDM in 5 seconds. So what we can do is, when you use TrustZone-based hardware protection, even if you have installed rootkits, even if you have a rooted device, you still cannot touch the TrustZone-based thing because it's a hardware-based protection. It's not a software protection. So a typical TrustZone-based data path works like this. Data comes through the phone as an input streaming encoded, like whatever that you see, the remote screen, right? The remote screen is sent as a compressed video format, and the compressed encrypted video is directly sent to the TrustZone world. The TrustZone world has a complete own memory, completely separate hardware block, and whatever that's running in the TrustZone secure world can never be seen or accessed from normal world. The normal world is what is running Linux. Linux has zero visibility. Linux thinks there is only like 0 to 3 GB of RAM. After 3 GB, there is 64 MB of RAM or 128 MB of RAM that's been allocated to TrustZone. So today when you buy a phone, they say, oh, we have 3 GB of RAM, right? There's always a hidden memory that's sitting behind, used for TrustZone for authentication and validation and everything. And also TrustZone can process IO inputs and everything. So when the chip is in TrustZone lockdown, none of the normal world applications can read the memory or can access IO blocks. So the actual keyboard input that you're pressing from the touch screen, which is I2C, is directly routed to TrustZone world. And so basically this is one of the things what we can do is on the endpoint to make sure your endpoint is completely foolproof and secure, irrespective of the fact what version of Android they run. They could be running a rooted version of Android, they could be running whichever thing is, like they could be just installing their own. They could just go to XDA developers, download the source code, recompile, boot their own phone. It's totally fine because hardware protection enables you to do certain things that Android doesn't do. That's pretty much the end of the presentation. Thanks for patiently listening to the whole thing. If you guys have any questions, feel free. So the question is it only for Android or is it for operating system agnostic? As far as the client is considered, the client can be operating system agnostic. The VMI gateway, right now, it's basically for Android. Because we want app developers. The most important thing for the VMI gateway is the app developer. If you use any other operating system, educating the app developer, or asking like guys like Dropbox and Facebook to write an app for a new OS, it's not going to happen, right? They've already written apps for Android. We can get them from Google Play Store. That's the reason we use Android. But on the client device, the end user device can be Windows Phone, BlackBerry, everything is supported. There's no issues on the end device because most of them are running on a similar architecture like a Qualcomm processor or the Samsung Exynos. They all use Cortex A57. They are identical chips, right? This is a different SoC ID, but the actual chip architecture, including TrustZone and everything, are identical. They use the same instruction for switching between normal and secure world. It's the same ARM processor, same Cortex A57.
Hi, hello. Thank you for the presentation. I see the clear benefits of the VMI approach for protecting the endpoint. My question is, and I'm sorry if I missed this, it might be the audio. How does the VMI approach handle the certificate pinning issue? If my application is checking for certificates, how do you block it, or how do you allow it?
So just to show you, right? When you host an app on a VMI gateway, you can do two things. One is you can actually, when an app is hosted on a VMI gateway, there's a container, secure container that is residing between the VMI gateway and the application. The secure container provides the entire operating system abstraction. So every call of network traffic, every time a packet is encrypted or decrypted, the actual encryption-decryption APIs are through the container. So at the application layer, you get a complete visibility of the decrypted traffic, right? Because the API that the app is calling, let's say the app is calling OpenSSL or like a Java API for decrypting the SSL call, that container is the one that's providing the OS abstraction, right? So the entire decrypted traffic has to pass through the container to the application. So the container knows the complete decrypted traffic. That is one approach. The second approach is the secure. The second approach is the Trusted SSL Proxy, which I was discussing. It actually, the Trusted SSL Proxy, what it does is, it is very similar to the MITM proxy. The one difference between MITM proxy and SSL proxy is, Trusted SSL Proxy is, the MITM proxy, when you connect to it, it's going to send you a certificate for the common name. So the common name is google.com, but the issuer will be the MITM proxy. Here, the MITM proxy will not create a fake certificate. The MITM proxy will just create a normal certificate and then connect to you, but also it will pass you the tunnel certificate back to you. So you know where the MITM proxy is connecting. Previously, when you're working with the MITM proxy, you have no idea how many MITM proxies are in between the user and the google.com, right? There could be 5 MITM proxies, 10 MITM proxies. Here, you don't want, when you connect to the MITM proxy, you don't want to have any more in between MITM proxies. You don't want to have NSA snooping. You don't want to have China firewall. You don't want anything. So you trust your IT MITM firewall, and you want to make sure your IT MITM firewall is directly connecting to Google. So what you expect from basically the Trusted SSL Proxy protocol, what it does is, it gives you the actual tunnel certificate back to you, which you can use for validating. So you ask your MITM proxy, or let's say if you're working for XYZ company. The XYZ company is hosting a Trusted SSL Proxy. You connect to it, you ask that Trusted SSL Proxy and say, who are you connecting to? Are you really connecting to google.com? He says, yes, I'm connected to google.com. Here's a proof of it. You take that certificate and use that for validating certificate pinning. Instead of using the connection, now previously what you do, you use a certificate that's used for establishing a connection for validating certificate pinning, right? Instead of that, you use the tunnel certificate for validating certificate pinning. You get the point? So basically, you are letting your MITM proxy in the IT managed network to inspect the traffic, and you tell them, I'm letting you under the restriction that you're not going to let any more MITM proxies to come in between the way. It's only you. I'm letting you to the gatekeeper, but once you analyze the traffic, you better make sure the data directly goes to Google, right? So that's the secure MITM proxy. These are the two ways you can help handle certificate pin traffic.
So if you're, hello. All right. Okay, there we go. If you're running in a man-in-the-middle proxy, and you're trying to, how are you actually verifying the Google cert is the one that's pinned? Because the pinning's done on the application side, right? In this case, for Google right now, they're using Chrome has it pinned, right? But if you're running a man-in-the-middle proxy, you don't actually have that information, right? You can verify that it's signed by a, quote, valid CA, but that could be China.
Yeah, so his question was, let's say if you're using Google Chrome. Google Chrome could come with its own SSL stack. Same with Mozilla, right? Mozilla comes with its own SSL stack, and it does all the work inside. Like there's no visibility for the operating system. Can we do anything about it? No, we cannot do anything about it. We can do only things that are using the OS APIs for doing all the work. If you find an application like Google Chrome, or if you're finding something that's very, very heavy-handed and comes with its own SSL implementation and not willing to do anything else, you are very, very limited. Let's say Google Chrome even has an option to have its own secure sandbox, right? They even completely take all the visibility of the file operations or anything else out from the user. It runs its own sandbox. When you're running inside a sandbox and coming with your own SSL stack, IT guy has to say, sorry, man. I'm letting you use Dropbox. I can let you use certain things. But if you're going to come back and say, I want to use Chrome, I'm going to say sorry. That's where it is right now. Thanks for all your time. And okay, here's our timekeeper. She's been so helpful. She probably ran 5,000 laps today.
Hello? Okay, this is kind of a stupid question, but this all appears to be designed for a phone connected to a Wi-Fi network. Suppose I'm trying to smuggle data out of a network or into it over the cellular connection, or even on the internal flash memory. This technology doesn't do anything to prevent that, does it?
So his question was, what happens if the guy is uploading traffic to Dropbox via LTE? So that's why we are telling, if you just use the Trusted SSL Proxy, it's not enough, right? Using just a Trusted SSL Proxy and saying, okay, that's going to be the way I'm going to analyze Dropbox traffic is not going to work when the traffic doesn't go through your own Wi-Fi network. That's why we are telling you, host the actual app on the VMI gateway. So if you host the app on the VMI gateway, the traffic always leaves through your corporate managed network. If you just use a Trusted SSL Proxy, what you're saying is perfectly true. There is no way to inspect the traffic that's going through LTE, right? But if you host the actual app on the VMI gateway, so using the VMI gateway, you are hosting the app on your own server, and the traffic leaves the server, goes through your IDS, IPS, and all your inspection devices through the Trusted SSL Proxy. So they have to work in conjunction. The whole thing is, the main thing is, if you're not hosting the apps on the VMI gateway, as you're saying, it's not a completely secure thing. Or you have to do like signal jammers and disable all the users from stop using LTE inside the office. Like use some kind of a MDM or something like that and say nobody should use LTE when you're inside the office. What you're saying is 100% a valid question because there's no easy answer for that. Thank you, everyone. Thanks for your time.